we can also take higher derivatives of vector valued functions. So let's say we have the vector valued function u equals t cubed t squared t. So to find u prime, we take the derivative of each component. It's 3t squared, 2t, 1. Then to take the second derivative, we take the derivative again component-wise. So 6t, 2, 0. And we can take a third derivative to get 6, 0, 0. And take a fourth derivative, we would get 0, 0, 0. And every derivative beyond the fourth, we would get 0, 0, 0. So let's try some examples. Let's find the derivative of following vector value functions. So we have 5t cubed plus natural log of t times r of 3t plus 11. So what this r of t means right here is that, remember how we have regular functions f of, t squared? Well, this is that same thing, but with a vector valued function. So this is some vector valued function r of 3t plus 11. And so let's see what we have. We have a scalar valued function, and we have a vector valued function, but we have a function inside of another function. So we know this is chain rule. And then between them, we have a product. So let's deal with, we know our product rule. If we call this, let's just call this f of t, and we'll call this r of g of t. So our product rule is going to be f prime of t times r g of t plus f of t times r prime g of t. So what we need to find are f prime of t and r prime of g of t. So f prime of t, this is a regular function, so we take the derivative, we get 15t squared plus, what's the derivative of natural log? Hopefully remember it's 1 over t, times r g of t, so that's r of 3t plus 11, plus f of t, which is 5t cubed plus natural log of t. And now here we need to do chain rule. This is going to be times, so this is going to be times this chain rule. So let's clear a little bit of space. So the chain rule gives us the outside, derivative of the outside times the derivative of the inside. So this is going to be r prime of 3t plus 11 times 3. So this is times 3r prime of 3t plus 11. So here we have our final answer. Looking at another example. Let's say we have u dot v of t. So u of t dot v of t cross w of t. Well, we know our please excuse my dear Aunt Sally. So our parentheses come first. So first we need to find the derivative of v of t cross w of t. And so that derivative, by our derivative rule, is v prime of t cross w of t plus v of t cross w prime of t. Alright, so then we have to do the dot product. So u dot, let's just call this thing x of t for now. So u dot x, so u of t dot x of t, and our dot product is u prime of t x of t, u prime of t dot x prime of t plus u of t dot x prime of t. So we know what our x prime of t is, and we need to find u prime of t. Well, we weren't given a function, so that's just going to be u prime of t. So our answer is u prime of t times this x, which we said was v of t cross w of t. So dot v of t cross w of t plus u of t dot the derivatives. So dot v prime of t cross w of t plus v of t cross w prime of t. And there's our solution. Alright, next one. We have t times 4t natural log of t, 3, plus 7 times 5, 6, 1. So we know that on this side, this is a constant times a constant. So this is going to be the 0 vector. Over here we have a scalar function times a vector function. So we find if we call this f of t and this u of t, we know that we get f prime of t u of t plus f of t times u prime of t. So f prime of t is just 1, u of t is vector 4t natural log of t, 3, plus f of t is t, u prime of t is 4, 1 over t, 0. So we get 4t natural log of t, 3, plus t times 4, 1 over t, 0. And we can simplify this if we want. So 4t natural log of t, 3, bring the t inside, 4t t times 1 over t is 1, 0, and then add our two vectors to get 8t natural log of t plus 1 natural log of t plus 1 and 3. Now let's have u try one. So u is the vector t squared, t cubed. V is the vector 6t, natural log of t, e to the t, and f of t is sine of t. So we're going to find the derivative of f of t times u of t dot v of t. So first we should do inside the parentheses. So the derivative of a scalar valued function times a vector valued function is f prime of t u of t plus f of t plus f of t u prime of t. So that will give us f prime is cosine of t, u of t is t squared t cubed plus f of t is sine of t times u prime of t is 1, 2t, 3t squared. And combining those, we get t times cosine t, t squared cosine t, t cubed cosine t, plus sine of t, 2t sine of t, 3t squared sine of t, t cosine of t plus sine of t, t squared cosine of t plus 2t sine of t, and t cubed cosine of t times 3t squared sine of t. So that is this part, and now we need to dot it with v of t. So let's call this one x for simplicity, x of t. So dotting, we get x prime of t dot v of t plus x of t dot v prime of t. So we just found x prime of t. Now we need to find v prime of t. So going up here, v prime of t is 6, 1 over t, e to the t. So dotting x prime of t with v of t. So this dot 6t natural log of t e to the t. We get 6t squared cosine t plus 6t sine of t plus t squared natural log of t cosine t plus 2t natural log of t sine t plus e to the t cubed cosine t plus in there, plus 3t squared e to the t sine of t So that is this part right here. So now we need x cross v prime of t. So where's my x? So x is f of t times u of t. This is my x, so f of t times u of t is the vector t sine of t, t squared sine t, t cubed sine t. So now we're dotting these two vectors. So we get 6t sine t plus t sine t plus e to the t, t cubed sine t. And so we need to add that to this right here. So let's go ahead and rewrite these close to each other. So 6 t sine of t plus t sine of t plus e to the t, t cubed sine of t plus this.